Hello guys, today I'd like to correct the homework with you that you did before. Here the homework was page 15 in your textbook. Start by question 17, okay? Look here with me. In exercises 17 to 26, use the graph to find the limit. If it exists, if the limit does not exist, explain why. Here, as you know, here I have the rule and I have a graph. I have the function already. And the function is polynomial function. Is what? Polynomial function. I can find the limit by substitution. But I did this one as a check to my answer because he asked me to use the graph. Okay? Here, I told you before to use the graph, I have to follow this procedure. I have to find the behavior of the function from right. As x approaches to 3 from right, go with the right part of the graph. Okay, from the right until I reach above 3 here as the graph, then takes the value of y. So the behavior of the function as x approaches to 3 from right is 1. Okay, as we approach to 3, what is the meaning of approach? Very close to it. And from its right, it means from the values less than 3. Go with the curve of the function until from the the left part of the curve of the function until I reach above 3, then takes the value of y is what? 1. Since the behavior from right as the behavior from left, okay, so the limit exists and it will be what? 1. If I'd like to make sure from my answer, just replace, use another way. I have two different ways to find this function, or 3 different ways. I can use numerically, graphically, or by substitution, since the given function is a polynomial also. But here he asked me to use the graph. I have to use this way as I showed you, because sometimes maybe I will not give you the rule of the function. Okay, if you replace, it will be 4 minus 3, it will be 1. 4 minus 3, it will be 1. So my answer is correct. Okay. I already explained this one when I was in the class. Here, the second question, number 18. Here, to find the limit of this function, which is a quadratic function, as you see, when x approaches to 1. Here, I have to identify what is x on the x-axis. Okay, then, as I approach from right, go with the right part of the curve, which is here, until I reach what? Above 2, it will be 4. Here, 3 here. The behavior from right as the behavior from left. As I approach from left, I reach it to the same value, so it will be 4. I'll tell you another way. Since I don't have, the curve of the function does not have jump or unbounded behaviors, the limit exists. Again, add to here, as you see, we don't have jump like this one, the same shape. No, I don't have jump. I don't have unbounded behavior as here for this one. It means go infinity or go to negative infinity or positive infinity. If the behavior of the function doesn't, it has the same behavior from right and left, okay, but in this case, it doesn't have the same behavior. So, the limit exists. And also, unbounded behavior like this one, infinity to negative infinity, the limit failed to exist. That's what I explained to you before. The limit failed to exist if the function has unbounded behavior, or it has different behavior as x approaches from left or approaches from right. Since here I don't have any one of this case, the limit exists and it will be the value of y corresponding to this value of x, which is 4. Clear or not clear? Here, again, Question number 19, as you see, this function I can't substitute in it because we need to redefine this function, never to substitute in it as a polynomial function or trigonometric function. Some function I need to redefine. But here he asks you to use a graph. Here, the behavior, where is the limit to when x approaches 2? I have to identify where is 2 on the x-axis in this graph. Okay, on this graph, okay? As we approaches from right, it approaches to what? 1. As we approaches from left, it is approaches to what? -1. It has different behavior. But the others one, they know the answer mentally and very quickly. Means we have a jump at x equal to any function, its graph has a jump at a given value of x. Its limit is what? Does not exist. That is one of the cases at which the limit failed to exist. Okay, as you see here, I find the limit when x approaches to 1. Where is 1? Please focus. I can find the behavior from right. As you see, from right, the curve of the function until it reaches above, it will be 4. From left, it will be by the same way. Go with the curve. It will be what? At 4. But I told you before, since we don't have this function doesn't have unbounded behavior, or okay, doesn't have unbounded behavior, okay, or doesn't have jump, so the limit exists and it will be the value of y corresponding to this value approximately. Approximately what? At here it will be 4. I hope it's clear. But it's better for you. As we approaches from right, the curve of the function, go with the curve of the function at the right of 1 until I reach above 1. Okay? Then take the value of y, that is the limit from right. As we approaches to 1 from left, to go with the curve of the function until I reach above, it will be 4. In this case, the behavior from right as the behavior from left, so the limit exists and it is what? 4. Clear? I think it's so easy. Now, I'll correct the other homework. Wait. Here, this one, focus with me. Here, this one, question number 21. Limit sin pi x when x approaches to 1. By the same way, I don't have in this graph, I don't have jump at 1. I don't have jump. What is the meaning of jump? Like this one. 1 down and 1 up. We have discontinuity in the curve of the function. Okay? 1 up and 1 down at it, it means we have a jump. Since we don't have jump, we don't have unbounded behavior at this one, I don't have these two cases at which the limit of the function failed to exist. Okay? So, the limit in this case, it will be the value of y corresponding to this value of x, which will be 0. By another way, as we approach from right, go with the curve of the function, with its right, it will reach at 1. Maybe the curve of the function reach above, below, or at it. The curve of not so takes the value of y, the limit from right equal 0. The limit from left, as we approach from left, go with the curve of the function, but here it will reach to 1, not above or below. Then take the value of y, which is 0. I give you many different ways. I can use this way, or sometimes it's too clear. I can define. I have 3 cases. Unbounded behavior does not exist. Like this one, the curve of the function go to infinity or at vertical asymptote or negative infinity. Okay? The second case, when we have jump like in this problem, like in this problem. So at 0, the limit does not exist. Why? Mentally. Okay? Here, when x approaches to 5, it is what does not